Hello and welcome to the 143rd Audio Engineering Society Convention. This is a broadcast and streaming special event tonight for a limited audience. We have John Lyons giving us a talk and tour of One World Trade Center. The building is ready for the television stations to return and resurrect their signals from the disasters of 9/11. I want to just do some housekeeping first. If anyone has questions when John opens up the floor, please wait for the microphone and also identify yourself. This recording will be used hopefully on the internet and so forth, so please keep your language clean and just remember we're guests of One World Trade and John. And also, please be careful where any photos you might take are posted. Tomorrow, our sessions will continue at 9 o'clock in the morning in room 1E08. And we have sessions all day for broadcast and streaming and throughout the rest of the convention. I invite everybody to see the sessions and attend. Now, I want to introduce John Lyons, who I've known for many, many, many years, from the time he was at WRKS, and I've known him through his career. We've worked at some places together. We've worked at a lot of places apart. John has the unique reputation. When I first met him, he was the chairman of the Empire State Building Master Antenna Committee. So he had something to do with the master antenna planning back then. He has built Times Square twice, and he has now built One World Trade Center. So he has really changed the face of FM and TV broadcasting in New York City and has now built the highest broadcast facility in the United States. John?
Okay, first, thanks everybody for coming. And as I go through this, I'm going to sit down. I injured my foot, so standing is a little difficult, and it's starting to bother me at this point. So hopefully you can hear me. The only noise coming from the floor right now are the fans in the server rack over there, which unfortunately I can't turn off. Before I begin, you are sitting next to a live TV transmitter. The transmitter is putting 67 kilowatts out right now, WNJU on channel 36. So that is live. It's a water-cooled transmitter, hence there's not a lot of noise coming out of it, unlike the old air-cooled days of all of us who worked in broadcasting for years and are used to 115 dB of noise coming out of a fan of a transmitter. So we did it over here rather than in the other part of the floor. We are under construction, as you can see, and you'll see that when we tour later on. But this one is live. The combiner at the other end of the floor is live. So don't be touching anything that you could possibly turn off. I think WNJU would be very upset if I shut them down at the moment. CBS is this space here. All this cabling was put in today. This is not live. This stuff you can touch. It has not been connected yet. Richard Mullen is here from CBS. He can answer any questions about their facility. He was nice enough to come in late tonight and be with us to help tour around. So any questions? Chris Tobin, who's walking around with the mic, is also somewhat familiar with the facility. He's there doing some work for me on GPS, et cetera, in the building. So we do have a couple of other people you can ask questions as we walk around. So to begin very quickly, and I am going to sit, hopefully you can hear me. And Kirk, if you need to readjust the camera, I'm sitting down here. The little history of the building. These slides, some of them are courtesy of Alan Reese from the Port Authority and also Doug Long of WNJU from the original facility. So they're not, the historical stuff is not in any specific order other than lifting up a 20-yard container to the rooftop in the first shot here. So this is just some of the antennas that were up there, just to let you know what was there before and what we're adding now. Just different pieces of the spire going up from the rooftop, which was an elevated rooftop, All of the antennas in the left-hand photo. On the bottom there are two-way radio antennas. On the new facility, we have 3 rings wrapping around the top of the building that those antennas are on, as opposed to being on the flat deck of the building. Again, just different sections of the superstructure being put up as it was built, lifting it from the street. The sections today were lifted the same way from the street with tower derricks and brought up to the rooftop and then set. And the top then and the top now look a little different. Just a bow tie antenna at that time for the VHF channel 4 and 5, and the rest are the panels for the UHF antennas, and the FM was in the middle. There's your high anxiety shot looking down from the top. As you can see, as I said earlier, the two-way radio antennas are all here on the roof. This was a CNN ENG dish that I actually put in way back when. But this is what it looked like then. Tower 2 is over here, and if you are walking around the Memorial Park where the 2 pools are, those were the actual footprints of Tower 1 and Tower 2. So we are just north of the original Tower 1 over in this area now. And that's a picture you probably won't see today of any riggers walking around in a tree climbing belt, not secured to anything, smoking a cigarette, and just hanging outside the building, basically. That's the rules have changed a little bit in the last 40 years. These I took right about 9 months before that day, 16 years ago. The ENG antennas and stuff wrapped the bottom of the Spire, and the standby antennas were low. Standby antennas were low, the FM was in the middle, and the primary antennas were up on the top. The ENG and the two-way and the point-to-point microwave were all wrapped around the middle. All of this ancillary service now is on the 3 rings, so if you look at the building from outside, you'll see those 3 rings. Unfortunately, with it being dark and late, and there is construction on the roof, we can't go up there, but you look at the pictures and you go, okay, fine, that's nice. You've got these 3 little rings. Well, those 3 little rings are 750 tons of steel. Sitting there on top of a rooftop of a building. So, yes, the building, but still a building. And the new Spire itself is 781 tons, also sitting on the rooftop of a building. So just put that in perspective when you look from the ground as to what you're seeing. And that's what was left of the area, about 120 foot up the tower after what happened. That was the hatchway. This was the RF safety shield, and that's what you climb through, getting up into the apertures. So, getting started down here, the tower sections, the bottom 9 sections were shipped from Canada by barge down the Erie Canal and down into the Hudson River. They were then brought over by barge to the building. The top sections came by truck, and they were brought to the site. This is the property manager of One World Trade Center and myself on the barge in the laydown yard when they first arrived. Here they are coming across the river as they pass the Statue of Liberty from New Jersey where they were anchored, and then subsequently coming towards the building. So hopefully I'm not blocking you over here. As I said, these were brought up in pieces one at a time to the top, and then brought up and anchored. The upper sections were married, 2 sections on the ground, and then hoisted in pairs because they were obviously considerably lighter than the lower sections, and they could handle picking them up. If my memory is correct, the 2 tower derricks were 120 ton capacity each, so they had a good lifting capability to lift this stuff to the rooftop. Top section, they put the flag on. If you're looking now at the top section, the prism section is still live. This is still there. This crow's nest has been removed. The top UHF antenna actually goes up to just about here. So we had to remove this section to put it in to get the top elements of that antenna in. And there's the top section going up with the immediate section below it there. All those pegs, those climbing ladder sections have all been removed. That's all antennas now, and the climbing ladder is integral to the antenna. It's there's about this wide compared to those 24-inch wide climbing shelves. I put this in there because this guy was dealing with the tag line, keeping that aligned. And you notice all his coworkers standing around doing absolutely nothing. This poor guy was on that line for 1,368 feet till they got that section up to the rooftop before he let go of that line. So I have to honor him for that diligence in doing it. As we go up, again, this ice shield, as I said, this crow's nest here has been removed, or this one's been removed. These are lights that were put onto the structure before it was lifted so it could all go up as a unit. And there we go as we're climbing the top. The building was still under construction when the section was finished up. And that was brought up May of 2013, so it's almost 4.5 years ago now. This is perspective. I'm standing on this ice shield at this point, this one, as they were building it. These are the stations that are up there now. We've also now adding WWOR, and on this antenna we're going to have WNYW. The 2 Fox stations have now joined this group of stations. So this was as the antennas were going up. There's the first antenna panels going up on the UHF up here, and you can see in this shot the crow's nest is gone. So we laid this out because NJU and CBS are both very high power, so I'm spreading the load over the 2 antennas, and then the composite of the other stations balances them out. So I'm essentially putting out the same signal on the 2 UHF antennas, and the VHF is in the middle, which has Public Broadcasting Channel 13 on. These will be all changed. This is for future antennas. There's some later pictures that show a little bit more structure, but everything was lifted piecemeal. All these antenna panels were lifted one at a time. These were lifted as 2 by 3 foot panel sections to make up the 96 that are here. There's 40 panels here. There's 16 panels in the VHF. These are the 3 rings I was talking about on the top of the building, and they're about 250 tons apiece of steel that will have ENG, electronic news gathering antennas, 2-way radio antennas, microwave point-to-point antennas, beauty cameras for the television people who have the beauty camera shot in the back of their newscasts will all be on these rings. This one right here is actually a camera looking down the skin of the building, one of 2 that Legends, the observatory, has. They have an indoor area that's a glass floor that you can walk on, but it feels like you're outside because it's actually projecting that camera shot underneath your feet. So you're totally safe, but you have a big, about a 15-foot diameter circle you're standing on, and you're standing outside the building. This is in here just for some background. We did a test antenna in 2015 for the TV broadcasters. They wanted to see what the signal actually looked like from this building as opposed to what was coming from the Empire State Building. They wanted to be certain they didn't lose any coverage immediately in the near field area below the building, and they wanted to make sure that what they got going north above Empire was equal to or better than. So we actually put a single face of antenna panels up, a UHF and a VHF on top of each other. And this was the mount where the pole sat. There were 2 of them because they wanted to have it looking at Manhattan Grid North, which is the avenues in Manhattan, for those of you not from here, is actually 29 degrees off true north, but that's called Manhattan Grid North. So they wanted to go up that, and they wanted to be able to go plus or minus 30 degrees and see what the coverage was, so they could effectuate what the coverage was going to be in the areas of concern. So we had the structural engineer design this gimbal mount, so the pole actually sat in there, and when they got it up there, they actually scored it every 15 degrees. So when the guys had to move it, all they had to do was go to the next notch, and they could land it, and they knew exactly where they were. And that's what it looked like from the other side. Just for a little background. There they are working on the first panels. As you can see, it's a little bit warm up there. Just the one section. This is the top antenna that was put up the UHF with a much oversized pole that was much heavier than what was needed, but they didn't know what they were going to be dealing with at the time. These are the 2 test antennas up in place. The VHF is down here and the UHF is up there. This is the VHF panels going up, and they said we could orient them plus or minus 15 degrees so they could see what the coverage was in the marketplace. The Metropolitan Television Alliance, the MTVA, for those of you who know them, did some measurements back about 5 years ago on a single frequency network, and they wanted to see what the coverage was, and they actually had a test transmitter at 4 Times Square on one system and a test transmitter on the Empire State Building on the other system. And they had all these points set up, GPS coordinated in their computer, and they could go out and measure those spots to see what the coverage was. Since they had that database, they reused that, and they added another 100 points to it to test down here. So they already had established what was coming off Empire State Building, what the single frequency network channels were projecting, and they could compare it to what was here. So this is mostly looking at Manhattan and northern Queens. This one is showing upper Manhattan, lower Westchester. And they knew they had a null from the Empire State Building along the Long Island Expressway. So they added all of these points out to the radio horizon to see just how much null fill they actually were able to get. This is an overview looking at the New Jersey area they covered and up and down into Brooklyn. Obviously, it's safe to say that the test was successful because 7 of the TV stations are now either on the air or building down here. Some of the things, great picture after traveling to Australia, 26 hours, that's what you look like. The antennas are all from RFS. That's Phil Sindrich from IAT, Nick Wyman from RFS, and myself at the plant in Australia, getting ready to proof the antennas. Over the period of time, I made several trips over there to do that. This is what the UHF antenna panels look like inside. They're set at plus and minus 45 degrees to get an elliptical pattern, which essentially gives you a circular pattern when you're done. They're pre-calculated through the combiner to actually do the offset to bring them up to what the FCC would accept at 0 and 90, because these are plus or minus 45. That's what some of the panels look like in the assembly line. The radomes actually are manufactured for RFS in New Zealand and then shipped into Australia to be assembled. Power dividers, we bring up the lines. As you can see, some of the transmission line over your head, and you'll see down at the combiner end. 2 8-inch lines, 2 7-inch lines, and 4 4-inch lines. The 8s and 7s feed the 2 UHF antennas, and the 4 4s feed the VHF antenna. But they then go up and they power divide down and down and down into smaller lines and essentially hit all the antenna panels and at 7/8-inch transmission lines. So going in case from 8 to 6 to 4 to 3 to 7/8, and any combinations depending on which antenna they're feeding. On the test range, we did a 2-section of antenna. They're 8 sections high. That's the PEP 40, the upper UHF, and you can see the integral ladders in it. And then the PEP 96 is 12 around. That's 5 around, 8 high. This is 12 around, 8 high. And again, you can see the ladder sections being built into the antenna. So all of those climbing pegs and everything that was put on the building had to be removed and retrofit before we could actually put up the antennas. Again, other pictures of the antennas on the range. The way they test these is they actually generate a signal from another antenna, and they use these as receive antennas set in the field exactly within the aperture, and this rotates on this base 360 degrees so they can see what the antenna is receiving, and that correlates to what it would be transmitting. So they did that with the upper U, the V, and then later on the lower UHF antenna. We then got the whole team together. The guys from IAT, the guys from RFS, the guys from the electrical concern who put it together, and the structural engineer, and we all went over all the drawings so everybody would know how this went together at the factory so we could reassemble it here. Some of the fittings before they're coated with the gray paint that they used to put outside. And there's part of the motley crew that actually put this project together. And at RFS, whenever everybody goes over to the plant, they do a picture on the staircase, so there's their official photograph of the group. RFS also manufactured the combiners. So there are 2 combiners for UHF, plus 45 and minus 45 feeding one antenna, and the same feeding the other antenna. They are absolutely identical, except that this one has 8-inch outputs, and the other one goes from an 8 to a 7-inch output to the other lines. Other than that, parts are totally interchangeable. They're mirror images of each other. And that's what it looks like through the mask filter, the 6 megahertz sharp cutoffs on it, so it's showing that any technical people, that is absolutely on channel, nothing extraneous going beyond what's allocated for any specific station. And we even had time for golf in Abu Dhabi on the way over. And that's the whole team at RFS to put it together, and a few of us other hangers-on who came from the States to do the testing. So, now moving back to here. As I said earlier, all these pegs were up there. They all had to be removed to put the antennas up. RFS designed adapter plates to go into the mounting holes that were originally put in the Spire to put those antenna panels on by utilizing what was already in place. The antenna panels just snugged right onto there. Some of the first panels going up, and here you can see them being built. As I said, they went up like that, about 4 at a time, and then they were put in 1 at a time. The connectors put on each one of them. That's as we're getting close to the end. You can see part of that catwalk or crow's nest still being there. They needed it. They used it for hoisting. And this is the view inside. We put a set of climbing pegs also inside the tower. For those of you who aren't familiar with towers, those pegs are about that wide, enough to put your foot on, and that's it. And there's a view with the cable looking down from the ladder. All the cables were color-coded, so they knew exactly which one went where. They matched antenna to cable, so everything matched what was done at the factory. Cable management inside, they actually made some blocks so these lines actually go in and you could stack them 4 across as deep as you wanted to go just by changing the threaded rods, or you could go out wider and put them in that way. So that's all interlaced up inside that way. And here's the antenna, the top antenna with the interstitial radomes between the panels, which acts to make it a one panel for the wind loading. Again, sections going up, and this is the power divider you saw in pieces from the plant. Here's the guys actually putting it in place. The other one is on the other face. This is feeding the top antenna, and there's another set lower down to feed the bottom antenna on opposite faces, and the VHF are on the faces opposite that. So if you look up at the building and you see funny looking things hanging there, you really can't see them from the street, but that is about 20 feet long. This is a 40-foot section. And there's your typical wow shot from the top. Looking down through the grating, the transmission line going up. Down here, it's all copper. Up here, it's copper. It's been solar coated. Each antenna, the UHFs, there's two lines going up. We have to keep them in phase. By solar coating them, we don't have any effect from the solar radiation from the sun, so the thermal effect is minimized. We actually did a test of the 2 lines from pre-sunrise to post-sunset. So we had the cold air, the sun going up and going down, and the solar coating kept the phase between the 2 lines of less than a degree off over the course of the whole day. So the solar coat is definitely effective to control any thermal effects of the sun on the lines. And there's just another couple of views looking down from the perspective of the guys up there working. On the rings, we have ENG antennas, STL antennas. These happen to be WNJUs from this station. They have 3 of these placed 120 degrees apart. NBC has 3 of them placed 120 degrees apart, 45 degrees off of these. 2-way radio, GPS, studio transmitter links are on the next ring down, and the bottom ring we were originally not using for anything because that was the escape route for the window washers. We're changing out the window washing rig, so now that whole 3rd ring is now open to me to populate. GPS lower on this slide. Rather than have everybody put GPS antennas up, we actually have 4 GPS antennas on the 4 cardinal points, north, east, south, and west, feeding down to a room on the 104th floor where we have a distribution system to feed GPS to anybody who needs it coming off of those antennas. They just plug in, pick it up. GPS is RF. They can plug in and pick it up as fiber. We also have a rubidium backup, so we're generating 10 megahertz clock up there. So if we lose a GPS signal, we still have clock being generated. And Chris, through DSI, has put in the fiber between there and here. They did the GPS system, distribution system. And we actually brought it down. We have 6 bundles of 72 strands of fiber connecting 104 to 90. That's internal to the building that other tenants and others have no access to. So they can run, every broadcaster has glass running back and forth. They can use that for whatever facilities they need to get from the rings to this floor. These are just some views of the east face, under construction, the west face, north, and south. The Durst Organization, who I work for, co-owns the building with the Port Authority. It's a joint venture. We are a very green company. 4 Times Square was the first building that actually set the gold LED LEED standard. Before LEED became an object, that was a building that kind of got it started. One Bryant Park, our main office, is the first commercial office tower that's platinum certified. So it's a family tradition, family heritage. We also have an organic farm upstate New York. All of the tenants who have cafeterias subscribe to that. All their compost and waste goes to the farm. We also buy recycled paper and all that. And again, the tenants have all bought into that philosophy. Part of that effort was to bring the power up here in a useful, non-wasteful method. So everything being 480, we didn't bring 480 up from the street. We brought it up at 13.8 kilovolts. And we're actually converting it to 480 on the floor. So that's a 13.8 feed. There's 2 of those. Primary and a backup feed coming up the building. That's the feed. If we did it at 480, we'd have 20 of those in each riser closet to get the same power up here. We put the dual-ended substation up here. Those are the transformers as they're being built. The floor is all EMF protected, so we don't have 60 hertz running all over the place coming out of there. That's the room across the hall. I cannot show you that because it is 13.8 kilovolts, and the Port Authority has everybody who does not need to be in there locked out. Much better safe than sorry. That's the door across the hall. I'm going to go around some of the other facilities being green. This is what you're looking at behind here. These are the pumps from the combiner, which is on the other side of the floor. And Gates has slightly different pumps in the CBS area over here. But essentially, they're the same. They're pumping glycol water mix. They're doing 39% glycol, 61% water. They're doing 50-50. Different philosophies in the two different companies, but essentially it's a glycol loop to help with the cooling. Transmitters are all water cooled up here. We exhaust the heat through brazed plate heat exchangers here on the floor that go up to the 103rd floor where they hit another set of plate exchangers that go up to the cooling towers. So primary loop is an open water loop that exhausts the heat into the air, goes to the 103rd floor, which is in a closed loop from 103 to here, and then we go to the heat exchangers with the broadcasters to then go from the plate exchangers to the transmitter and the pumps. The only area that is glycol is down here on the floor. Just some of the pumps as they were being set up. What we also did above the top, you'll see some green flashing lights if you look up above the transmitters on the active ones. We have energy valves on it. These modulate the water. We keep the delta from inlet to outlet temperature of 10 degrees so that we're not wasting water up on top. We're supplying what's needed, no more, no less. And also the pumps, both the ones that I just showed you and these pumps are modulating pumps. So if we're at, say, 9.5 degrees and they really want 10 degrees, these will ramp up a little bit to get that 10-degree delta. So we're really being energy efficient with the use of the water in the building. This is what's behind you as they were building it. This is WNJU. Before they went on the air, they were still building at that time. As I said, this transmitter is on the air. It's been on the air since June 23rd. It's running to the top antenna, which is live at 67 kilowatts. When they move to their main antenna, which is the bottom one, when it's finished later this year, it'll be running, I believe, licensed power is 97 kilowatts. Richard on CBS is going to be running about 80 kilowatts, I think, licensed power, transmitter power. It's not effective radiator power. And again, being water cooled, the noise level is going to be like this. For those of you in broadcasting, especially those from years ago, we could not be having this conversation now in this environment because the noise would be worse than a jackhammer by about 20 degrees of the noise coming out of the transmitter from the air-cooled transmitters. Water-cooled has definitely made a considerable difference to both everybody's hearing and work environment. This was, as we were testing this transmitter, they were running at that point 65.46 kilowatts, 99% power. And this is just a screen of the control in there. This is the VHF combiner and the 4 transmission lines that go through the wall and upstairs for the VHF, because they all have to be phased the same, so the signal goes out all 4 antenna arrays at the same time. You have trombone sections of varying lengths to make that phase be. By the time it hits this wall, they are all absolutely at the same part of the cycle. Again, different shots of the energy valves in the other location over there. Being green, all the transmission lines came from Mayat across the river in New Jersey. It's about 30 miles away. They ship all their line in boxes. Well, I didn't want boxes being manufactured 30 miles away and brought here and discarded, whether they went into a landfill or they were recycled. So we did a program with them that the truck came in with the lines, the next truck that brought the next load in brought the empty boxes back, and we recycled the boxes until they were really unusable to go, and then they were discarded, and we do have a recycling place, picked them up. They didn't go to a landfill, as cardboard was recycled. I talked about the solar coating in the Spire. This is a shot later on when all 8 lines were in, all the springs were then tensioned. For those of you not in the broadcasting arena, copper, 300 feet, 400 feet of copper moves about plus or minus 1.5 inches, depending on summer or winter in the city of New York. So everything is on springs. They're fixed hangers, top and bottom, springs in the middle. The springs are tensioned to the temperature in the environment the day they're put in. If it's 65 degrees, the spring may be tension 15 inches. If it's 85 degrees, the spring may be tension 12 inches. The tension on the day they were put in, so overall, depending on whatever the temperature is, the springs are tensioned properly, and they'll all move together, because the last thing you want is things to be splitting, O-rings to be opening up or whatever. So, being the World Trade Center, security issues, and everything else, trucking, logistics was very important. As I said before, the antennas came from Australia, the combiners came from Australia. They were air-shipped, which meant they had to be laid horizontal to fit in the cargo hold of an aircraft. Coming into the building, you came up in one of the elevators. They're vertical, they're not horizontal. Everything went out to Myatt, was restaged. Some of the stuff was left the way it was and just stood up. Others couldn't be. The plant in Australia actually took all this into consideration, and they told them, okay, you remove this board, this board, this board, you have to stand it this way, you can't stand it that way, just to deal with the logistics, which was a nightmare. Shipping, security, and everything else. The trucks, anything coming into this building, the drivers have to be identified in advance, and the VIN numbers of the vehicles have to be in the system. If they don't match, you don't get in. That's simple. Broadcasters will have a trusted worker program so that they'll be identified, they'll all be security worker access scanned ahead of time so we know who they are. All the secure areas are biometric readers and swipe cards. You need both. So if somebody cuts off the finger that's in the scan, you're not getting in. Everything was 3D rendered, the whole job, so that we can make sure, as you can see, I've got 23 vertical feet above me, well, 17 above me. Everything had to be in proper layers so that everything could pass each other. So the water is all at the same height. The electric feeds, including the 13.8, which is identified, are at the same height. All the transmission line going across the floor will be at the same height. All the duct work. Again, everything had to be layered in to make sure it would all work. Unfortunately, having a 23-foot ceiling in here was able to function. If it was a normal height ceiling, doing this would be an absolutely impossible task. So we had an architectural firm do all the 3D modeling. You can actually see in this shot, there was a hit right here. We had this water pipe hitting this line. We had this pipe smacking into that line. That's why everything was done in color, so they could see where the hits were and do all the adjustment. And that definitely helped in the hallway, because we have input lines from the transmitters to the combiner in some cases, and output lines in going back into the hallway and into the shaft to go upstairs. So there's a modeling of that. The upper lines are the two lines you actually see over Kirk's head there. 2 other lines in the wall there going to the combiner down the hallway, and the 8 lines coming from the combiners going back in the hallway to the shaft. And the next shot, I had to turn it 90 degrees to fit it in, but remember what you're seeing here, and there it is in reality. So just to make everything fit, and also to make sure, for those of you in broadcasting who have worked in tight spaces or in the original Trade Center, as Harold can attest to, lines were put in smack together right next to each other. If you had the line in the rear that had to get out, everything in front of it had to go. We made sure there's spacing to remove every single piece without affecting the adjacent hardware to it. This is the 7-inch line going up to the upper antenna. This is a standing wave ratio. 1.2 to 1 is acceptable, kind of in the outside. Nothing here is worse than a 1.1, and that's only a couple of places. And this is actually the band that's going away when the repack takes place. Everybody's moving down to below 600 megahertz. So these little components that are actually here at just about a 1.1 will go away, and we only have a hit of 1.08 Viswar here, which is spectacular. Transmission line in itself is a 103, can't be lower than that for this size line. So the fact that the entire system going up to the antenna proves that everybody did their job and did it right. That's the one line of the 7-inch, and there's the other one. So you can see they're both very, very close. Again, the outer band components over here. Logistics. Elevators were measured. Crating had to be done properly to get it in the building. They actually took these antennas for the lower UHF antenna. We wanted them put up in 3x2s, otherwise it would have been 96 picks. Doing it this way, we had 16. It was still 16 times we had to hoist equipment up. So they actually made a mock-up of this and fit it through the corridors and the walkways and into the elevator to make sure they could actually get it on the roof and under the diagonal steel to get it up there. A lot of logistics went into making this work. Crates were marked, sized, right side up, truth tables to show whether or not it would have been tipped wrong. This is by the combiner section. Again, we're just dealing with RFS. I wanted the broadcasters to be able to get their own forward and reflected powers off the equipment, not being generated by me, where somebody could say, well, you fudge the numbers. They've got a home run raw feed right off a forward and reflected port, right at a combiner. Each station has their own pair. They take their own feed. The cable's running on the ladder rack. The black cable over my head going in there is their feed from those combiners to their equipment going back to their studio. So I have no control over it. They're seeing exactly what the system is putting out without it going through anybody else changing it, critiquing it, adjusting it. Up on the tower, we were fortunate to have Todd Loney here doing a lot of the testing for us for RFS, and they also were hired by WNJU to do their system testing. This is at the antenna input on the tower going into the antenna. Again, standing wave across the entire UHF spectrum is the highest point of 1.08. That's antenna only. Input to the combiner, that's what it looks like. Again, the upper part of the band is going to be gone. The actual part of the repack band, the highest feed there is a 1.08 across the entire system. This is one of the antennas. When they got it onto the roof, you can see they had to put wheels under it, change the packing, use the hoist to get this stuff under. That diagonal beam we could not remove. They had to get past that with everything. The elevator is about where I'm standing. So everything was based on that diagonal brace to get it past there. And that's what it looks like. Originally, they were planning on trying to pick a face at a time, the whole 32, or the whole 8 times 2, 16 panels at a time. But they decided that it was too much wind load, and it was easier to pick them up and mount them up on, get the mounts up and just attach them. So it was more picks, but more efficient. My project manager from Tishman, Pat Keating. Elite certified Marine, worked in Desert Shield, Desert Storm, did construction over in Iraq. Jim Graff, a lot of you know, master rigger, old timer. I've been doing this for a long time. I brought him out of retirement to finish this job, which he fights me on every day, but he's still here working. And there's Pat on the Spire. Pat did a lot of the pictures up on top. I think he's past his 51st climb now. He never climbed before. Went to climbing school, full protection, all the training, and he's my eyes in the sky. So, questions? Pat's friend, the pilot, took this shot at a trade center through the clouds.
If anybody has any questions, just raise your hand and I'll bring the mic over.
Right over.
FM. Any plans for FM?
There's facility for FM, but there's no plans right now. FM just redid a auxiliary antenna at the Empire State Building, and of the 21 stations in the group, 17 of them are already at 4 Times Square. So honestly, don't see the need for a third facility, and so there's room. You'll see as we walk across the floor, there is room for the FM combiners and transmitters, and there's aperture on the Spire to house it. But right now, there are presently no real plans.
Can you talk a little bit about the design plans, why you picked this floor specifically? Because how much choice did you have as the building was going up?
Actually, when the MTVA group was dealing with the Port Authority pre-2008, they had the 89th and 90th floor set up for broadcast. So these floors were actually poured to handle the broadcast load of the heavy transmitters. We realized when the Durst family got involved with the port in 2010 that we really didn't need to have demised rooms, individual spaces, individual air conditioners to feed all of that. It was more opportune to do a single open floor, which would make better facilities for air handling, electric, and with everything now being IP-based and password protected, the security issue is not like it once was. You're not going to have people up here fiddling around. As I said earlier, there's biometric and card readers on every door that affects anything that is of a secure nature for broadcast, so we know when somebody enters, and it's also on the doors going out, so we know when you entered the space and when you left the space. So if anybody's doing anything, there's cameras, as you can see in a few discrete places as well. We'll know who's on the floor, when they're on the floor, when they left the floor. So everybody felt, and after convincing the broadcasters they didn't need it, they all bought into that idea, and what you see now is people being in spaces next to each other. Quick overview while we're on that subject before we move. WNJU, WNBC is going to be channel sharing out of this transmitter. You'll see NBC on the racks at the end. They have signal up here now. They're probably going to be broadcasting from this site at the end of the month. CBS is building right here presently. Next to them is Ion Media, and next to that transmitter is WNET Public Television. We'll see that as we go by. The space you're sitting in, from 4 feet off the face of those racks to 4 feet off these racks here, this pie cut here is going to be Fox Television, WNYW, and WWOR. They'll be building later on this year. Their equipment's ordered, and they'll be coming in here over the next few months. Expect to be on the air early, one station in the first quarter, the other station in the second quarter of next year.
John, you mentioned that the Spire had to be modified when they were putting on the antennas. Wasn't the Spire originally designed for the antenna?
Spire was originally designed for another manufacturer's antenna that the MTVA group worked with. When that project kind of fell through in 2008 and they decided they weren't doing anything down here, the Port Authority had all of the appurtenances and cuts and stuff removed from the Spire. It was going to be purely an architectural Spire at that point, with a full radome covering the whole Spire. When we got involved and we were bringing broadcasting back to the building, I had to start from somewhere, and I had the Durst family actually talked to the Port Authority, and we had all of the cuts that were removed put back into the Spire, because if I had to cut or burn steel at height, it would have been a non-starter. The project just never would have taken place. So by having openings cut and having those bolt holes put in there, we were actually able to make our adapter plates to be able to utilize what was there to be able to build the antennas on it, even though we went to a different manufacturer than was originally planned in the original structure.
Was anything learned from the original Twin Towers that you were able to correct on this project?
Well, one thing is, several. My whole career has been learning what not to do and how to correct it. As I said earlier, the transmission lines, nothing is run next to each other, so if we have to take out a piece, we can take it out without affecting any other lines. So even if it's two lines feeding an antenna and we get a sour piece here, they can still feed half of the antenna and keep broadcasting while we fix the other half, without having to disassemble anything else. I know myself personally, working in the old Trade Center, we did have a line that burned out. It happened to be against the skin of the Spire. There were two lines in front of it. The burnout was 80 feet. We had to take out 100 feet of two lines in front of it to get to that 80 feet to remove it. They were also put in as 20-foot sections when it was being built. Can't get 20-foot sections until we've built Spire. So the replacement pieces had to be 10-footers. So now you have double the number of flanges that had to be adjusted for to make sure you didn't have molding going up the lines and the phase was all correct. So we made sure that everything is accessible. Everything can be removed a piece at a time with no interruption to anybody else that's broadcasting. Those are the things we learned from that, and also from things that I've done and say, okay, yeah, that didn't work, let's do something different. For those of you who don't know my background, I hit 51 years in broadcasting last month. Started in radio and FM, went to AM, went back to FM, and the last 16, 17, 20 years have been mostly television, but FM thrown in the middle of it. So I've been with Durst now 15 years. They brought me in after 9/11 to manage 4 Times Square and develop that as a site. It was an FM backup site. We took down the 132-foot tower there and rebuilt it as a master TV and FM site. Replaced, as I said, 132-foot tower with a 385-foot tower. 3 years ago, we took off the top mount Channel 68 antenna, which was defunct after the digital era, and we replaced that with a Channel 3 antenna for PMCM, who's broadcasting MeTV off of that site. So the 41-foot top antenna became a 75-foot top antenna, which meant I had to go back to the FAA and get the height all changed. Fortunately, when it was designed, when we redid it in 2002-03, I actually had that footage there and never gave it back. So it was just reissuing what we had previously asked for to do. So there's a little background of myself as well. Durst got involved in 2010 with the Port Authority. We went out to the broadcasters in November of 2012 with a proposition to come down here. The first leases or license agreements with the first 4 broadcasters was done in December of 15. We did the test antenna April to June of 16. And we started building this last year. We've been at this about First antenna panels went up August 31st last year, but we had to do obviously retrofit before that, before we got to that stage.
John, you mentioned the weights of the rings and the weights of the spire. What is the, with wind loading and everything, what can this roof really support?
The wind loading can support that total radome that was originally designed, which had a lot more vortexes around it than what is up there now. The structural engineer of the building has checked out every single thing we've added to that spire that could be affecting wind load, whether it be transmission lines up inside. And if you do structural analysis on something like that, that spire became a flat sheet of plywood essentially. But putting up stuff inside where you do have vortices around individual lines, we put that into the calculations. The antennas, the power dividers, everything being mounted outside, went back through the wind tunnel, through the wind study. This building is built much more rigid than the original trade centers. Those two buildings did sway. If you were on Tower 1 and standing there, Tower 2 occasionally did that past it. They were built that way. They were designed that way. This building is built a lot more rigid. The core of the building is 36 inches of concrete with rebar 1 3/4 inches in it. It was poured as a monolithic pour, which meant that it was still wet on the lower floors when the upper floors were added to it. And they moved the frame up as they built 2 stories at a time. So essentially they were building as one continuous pour, the entire building. So it is built as a much more rigid building. Yes, it does sway, but not like the other buildings did it then, when that was that design, which is now 40, almost 50 years old.
Jim Starzinski with NBC. Your capacity in terms of expansion and how many stations can you handle, and what's the maximum capacity of the plant?
We can handle every TV and FM in the market. We have 7 of the 10 TVs either built or building. 3 stations are staying at the Empire State Building right now, and we can handle all 21 FMs in the market.
And that's all the way around, so that's power, space, air conditioning, everything.
Air conditioning, everything, including bringing ATSC3 ready for television.
And also positions on the antenna?
Well, they're master antennas. There's 2 UHF, so we can split the power between the 2, and the way the stations are set, as you see, there's 2 transmission lines coming from each one, so they're actually feeding both antennas. They can use, in the case of WNJU, their main is going to be the lower, their backup's going to be the upper. When we go do a touring around, you'll see a patch panel. They can actually pull a patch and switch to the other antenna and operate on either one. The VHF, we only have 1 antenna here. The backup is actually at 4 times square. FM, we do not have an FM antenna here yet. If that comes up in the future, we have space on section 4 of the antenna, which is just below the lower U, to put an FM antenna in there.
And what's the backup power like?
We have a 2 megawatt generator feeding broadcast. We have 4 PDCs coming in from Con Edison that then come up as 2 feeds to the building to do 2 dual-ended substations at 13.8 kilovolts. We then convert it up here to 480. Generator's 13.8. So we have A, B, or generator. But A and B are also picking up an A and B from the street. So you have 4 coming in, convert to 2 coming up, and the generator. 2 megawatts just for broadcast. We have 300 tons of water for the broadcast for condensate water, condenser water, and air conditioning. But also that's one of 13 cooling towers that feed the building. So we actually, if we have to maintain A, we can go to any of the rest of them. Everything can be valved and set up. We're bringing water down here, and again, redundant risers from 103, redundant from the cooling towers.
How is the generator fueled?
Generator is diesel. There's 2 10,000-gallon diesel tanks downstairs. They are in a submarine environment with bulkhead doors and all that. The generator is on the 6th floor. It is above grade. All of the carriers, since we're on that subject, all the carriers coming in, Verizon, Tower Stream, Time Warner Cable, anybody else is coming in, comes from the manhole into the building, below grade, obviously, that's where the manholes are, up to the 6th floor. The BB room, the point of presence room is on the 6th floor. There is no breaks of any cabling below that can be affected. We brought everything up to that point. Sandy was a very good example of flooding. The site was open at the time. It wasn't a finished site. But as you know, there was millions of gallons of water in lower Manhattan at that time. So when we got involved again, we made sure that that room was put above floodplain by considerable amount and within the core of the building. There was another question up here.
Charles Trantham, Local 1, ITSC. You had mentioned that you were testing the effectiveness of the signal going out. How far out to Long Island did the signal reach?
Well, it goes out to the radio horizon, which is about from this height about 62 miles. Chris, does that sound about right? So we go out to that point, and again, the digital signal, unlike the old analog days where you started to gradually go to snow and the picture faded, digital, it goes off a cliff and gone.
So that's less than visual.
Yeah, it's the radio horizon is what it goes, the curvature of the Earth, and then obviously the signal's going out this way, so it's going to keep going that way. It's not going to curve around on these frequencies, whereas low frequencies do curve. From here, with WNJU, without talking out of school, they've effectively doubled their in-building penetration from this site over what they had previously. Yes, they've gone up a few hundred feet, but going up, you have to lower power. The FCC curves are at a 45-degree angle. So if you go up here, power comes in here. So you hit that, you still cross at that same point. So they've actually, from what they had lower level, they've actually lowered the power here. The repack, they're asking for a maximization, which all the stations are. They're all going to be going up a bit from what now into the upper antenna. I believe they've applied for 97 kilowatts on the lower antenna. CBS is operating at going to be 80 kilowatts here on the upper antenna, which will give them about a megawatt of power, effective radiated power. 780 kilowatts of effective radiated power.
Any other questions?
Mark Kars, University of Pittsburgh. So the original World Trade Center had federal government transmitters.
The legacy tenants have the right to come back here. So it's up to the port, and they're actually Port Authority clients, if you will. So they have a listing of who is here and who are looking to come back here. Port Authority actually is building too. They have a lot of stuff on the rings. It's obviously part of their building. But the agencies will be coming back. Most of those who were here will be back here.
Any other questions? Before we continue with the tour or anything, I just want to thank John for opening up this and the Durst Organization.